There is a molecule your body cannot function without. It's declining in you right now, measurably, irreversibly, unless you intervene. And there is a 90% chance nobody has ever mentioned it to you. The molecule is called NAD+, nicotinamide adenine dinucleotide, and it sits at the center of virtually every longevity mechanism science has identified in the last 2 decades. Energy production, DNA repair, cellular stress response, inflammation control. Research has now confirmed what the field has suspected for years. Systemic NAD+ decline is one of the primary driving forces of aging itself, not a symptom of aging, a driver. And here's the problem. Your body doesn't tell you when NAD+ is low. There's no pain, no obvious lab marker on a standard panel, no diagnosis. The decline is silent, showing up only as things you've been told are normal. Fatigue that sleep doesn't fix, slower recovery, cognitive friction, reduced resilience. But science now has a clear picture of what's happening, when it happens, why it accelerates, and what actually works to address it, including a head-to-head clinical trial published in 2026 that finally answered the question everyone in this space has been asking for years. This is Hidden Health Protocol. I'm Dr. Nathan Toll, and what I'm about to show you has been sitting in peer-reviewed journals while the supplement industry confused you about it on purpose. Let's establish the mechanism before anything else. NAD+ is a coenzyme, a molecule that makes other biological processes possible. It doesn't work alone. It works as a cofactor, enabling the enzymes that run your metabolism, repair your DNA, and regulate your cell's response to stress. 3 systems depend on NAD+ at a fundamental level. First, your mitochondria. NAD+ is the primary electron carrier in oxidative phosphorylation, the process by which your mitochondria convert fuel into ATP. Without adequate NAD+, this entire process slows. This is the direct link between NAD+ decline and the energy failure we discussed in the last video. Second, sirtuins. These are proteins, sometimes called longevity genes, that regulate cellular health, inflammation, and how your cells respond to damage. Sirtuins are completely NAD+ dependent. They cannot function without it. When NAD+ falls, sirtuin activity falls with it, removing one of your body's primary defenses against accelerated aging. Third, PARPs, poly-ADP ribopolymerases. These are your DNA repair enzymes. Every time your DNA is damaged by oxidative stress, UV exposure, metabolic byproducts, PARPs consume NAD+ to execute the repair. As DNA damage accumulates with age, PARPs become increasingly active, consuming more and more NAD+ from a pool that is already declining. The result is a compounding deficit. More demand, less supply, every year. Now let's talk about when this decline becomes clinically significant, because the timing matters more than most people realize. Population data shows NAD+ levels peak in early adulthood and begin a slow, measurable decline from there. But the decline is not linear. 2 enzymes actively accelerate it as you age. CD38, part of your immune system's inflammatory response, increases its activity with age and consumes NAD+ as a direct consequence of chronic low-grade inflammation, the same inflammaging we discussed when we talked about biological age. PARPs, your DNA repair enzymes, ramp up as DNA damage accumulates, creating an increasing drain on NAD+, precisely when the supply is already shrinking. This is why the 40 to 49 age window is where the research consistently finds the most pronounced decline, in men specifically. It's not one mechanism, it's 2 accelerators arriving at the same time, CD38 and PARPs both increasing demand against a backdrop of declining production. And here's what's crucial to understand. By the time you feel the effects, the fatigue, the cognitive friction, the slower recovery, the decline has typically been underway for years. NAD+ doesn't collapse overnight. It erodes, quietly, until the threshold is crossed. Now here's where it gets specific, and where I want to be precise because this space has been dominated by marketing rather than data. The question everyone has been asking for 5 years is this: if NAD+ declines with age, can you meaningfully raise it through supplementation, and which precursor actually works? In early 2026, a clinical trial published in Nature Metabolism compared 3 NAD+ precursors head-to-head in the same study, same protocol, same participants. The 3 compounds tested were NR, nicotinamide riboside, NMN, nicotinamide mononucleotide, and NAM, plain nicotinamide. The results were direct. NR and NMN both approximately doubled circulating NAD+ levels after 14 days of supplementation. NAM, the cheapest, most widely available form, produced only a short-term acute effect with no sustained increase. A second study from Norway in 2026 added another layer. When NR and NMN were compared directly, NR elevated blood NAD+ levels 2.3 times higher than NMN at the same dosage. What the research also revealed is the mechanism behind why NR and NMN work while NAM doesn't. The gut bacteria convert NR and NMN into nicotinic acid, a potent upstream NAD+ precursor to drive the sustained increase. The gut microbiome is part of this equation. This matters because the NAD+ supplement market has been selling everything from plain niacin to IV infusions as equally valid options. The head-to-head data now draws a clear line between what the evidence supports and what it doesn't. So let's put the complete picture together. NAD+ precursors, specifically NR and NMN, have now demonstrated in human clinical trials that they can meaningfully raise circulating NAD+ levels. That's a significant scientific development. But supplementation is one input into a system. Understanding the other inputs matters. Exercise, specifically resistance training and high-intensity interval training, activates NAMPT, the enzyme responsible for NAD+ biosynthesis inside your cells. This is not a small effect. Studies show that older trained athletes maintain NAD+ levels comparable to those of much younger, untrained individuals. Exercise directly supports the production side of the equation. Time-restricted eating activates sirtuins and reduces the chronic inflammatory activity of CD38, addressing the consumption side. Sleep quality matters more than most people realize in this context. Sleep is when your body's NAD+ dependent repair processes run most actively. Chronic sleep disruption doesn't just impair rest, it drives NAD+ consumption without adequate recovery. The framework, then, is not take a supplement and fix it. It's reduce unnecessary NAD+ consumption through inflammation control and sleep, support production through exercise and dietary timing, and address the remaining deficit with a precursor that the clinical evidence actually supports. The system responds when you address it as a system.
Let's close this. NAD+ is not a wellness trend. It is a coenzyme at the center of energy production, DNA repair, and longevity signaling. And its systemic decline has now been accepted in the field as one of the primary driving forces of aging itself. The decline is silent. It doesn't announce itself. It shows up as things you've already been dismissing as normal. Energy that doesn't come back, recovery that takes longer, mental sharpness that fades through the day. The science in 2026 is further ahead on this than most physicians are. Head-to-head clinical trials have now answered the precursor question. The biology is measurable, and it responds to specific, evidence-backed intervention. I've left a link in the description.